Welcome to a webinar clips video, our series where we show selected clips from our TMG EDU webinars. Today we will be revisiting a presentation given by Erik Foltz, a senior managing engineer on the processing team at TMG. His presentation is a dive into how the injection molding process affects the performance of your parts. If you enjoy the sneak peek of this webinar, the Madison Group has a series of webinars in the upcoming months, as well as a back catalog of our latest webinars that is available for on-demand viewing at our website on the bottom of the screen. Without further ado, here is the webinar preview.
So why are we talking about this? Well, as the industry evolves and as we're trying to go towards more engineered and lighter weight products that are more environmentally friendly, we're trying to put plastics in more demanding applications, right? We're using it in the furniture industry where they're acting as structural components, you know, for back supports and for the legs and the seat bottom. We're using it in the firearm industry where we're making the magazines out of the plastic materials now. And for quite a while, obviously, plastic's been a very prevalent material in automotive. You know, we're manufacturing whole front end components out of, you know, composite materials, and it's used in many different industries. And we're not only talking about performance in terms of, you know, strength and not breaking, but also as our devices get smaller and smaller, we're also focused on functionality and needing precision on dimensions so that we can use plastics in our, you know, in our medical devices, for example, or on our personal protective equipment. And then another big trend towards use of plastics is obviously metal to plastic conversion, where maybe we had a product made out of a metal and we had a certain set of properties and we came to a design. So then we wanted to figure out how to make that plastic or how to make that part out of plastic, and, you know, how we might need to modify that design, where, you know, maybe we're going to need a few more ribs here to support our bosses on our part. And so then we have to find a material that might suit our needs. And we may look at a data sheet and say, all right, I have similar strength in my material with this plastic material. I'm a little more compliant, so I can adjust my design to account for that more compliance. However, if we only take the simplistic approach, you know, we really miss the picture of what this metal to plastic conversion is all about. You know, we're going to have a certain defined set of loads on this part that we need to be able to withstand, and there's going to be some sort of distribution on that. Our aluminum or our metal component, we're going to have a certain set of properties that are very well tailored and very well defined within that component. However, as we start looking at plastics, we know that, you know, in the unfilled state, you know, we are going to have lower properties overall, and we're going to have some sort of wider distribution in our properties. And then when we start adding reinforcements such as glass fillers or carbon fiber, we can bump up where that median property is, but then we're going to increase our distribution. So when we really look at the data sheet values, which give us properties up in this region, we can see the probability of really achieving those data sheet values is very limited. And we really need to take a holistic approach to make sure we're optimizing our plastic and part design for that material. And when we don't do that, we can make a part out of plastic. We do our FEA, you know, it says the stresses remain low, but because we didn't account for that variability in the material properties of our part, when we actually test that part, we wind up getting a part failure that we weren't necessarily expecting. So how can we avoid stuff like this, and how can we make sure that our manufacturing process is taking care of the material?
Thank you for watching. If you enjoyed this video, please hit the like button to let us know, and comment below with any questions or topics that you would like to see covered on the channel. Also, remember to subscribe so you do not miss any of our new content. If you have a specific problem you would like one of our experts to discuss with you, please reach out at the contact information in the description below. See you in the next video.